Last chapter, we defined a linear pair as a pair of angles that are adjacent and whose non-common sides form opposite rays. So if I have adjacent angles whose non-common sides form opposite rays, I have a linear pair. Well, the linear pair postulate says if I have a linear pair, if I have two angles that form a linear pair, then I can conclude that those two angles are supplementary. Then the measure of angle 1 plus the measure of angle 2 equals 180 degrees. The linear pair postulate allows us to go from a picture, two angles being a linear pair, to an equation, those two angles summing to 180 degrees. We also defined vertical angles as two angles who share a vertex and the sides form one, two pair of opposite rays. So this angle and this angle are vertical angles. The vertical angles congruence theorem gives us more information about those two angles. If two angles are vertical, then those two angles will be congruent to each other. And if you look, that makes sense. These two angles form a linear pair, and these two angles form a linear pair. So these two angles sum to 180 degrees, and these two sum to 180 degrees. And since they both share this angle, that means that these two angles have to be congruent. Think about the converse of these two. Is the converse true? Well, if I look at the linear pair postulate, the converse would be if two angles are supplementary, then they form a linear pair. Well, can I have two angles that are supplementary that form a linear pair? Yeah. But I can also have two angles that are supplementary that don't form a linear pair. So is the converse true for the linear pair postulate? No. If I look at the converse of the vertical angles congruence theorem, if two angles are congruent, then those two angles are vertical. Well, can I have angles that are congruent and vertical? Yeah. Can I have angles that are congruent but not vertical? Yes, I can. So that means that the converse is not true for the vertical angles congruence theorem. So the converse of both of these are false. The reason that they're postulates and theorems is the fact that their converses are not true. Theorems and postulates don't always have their converse true. If the converse was true, I would have a definition. So theorems and postulates, the converse is not true. In a definition, the converse is true. Let's take a look at a couple problems that involve these two theorems and postulates. If I look at my diagram, I have vertical angles and I have linear pairs. So in this picture, my adjacent angles form linear pairs and my angles across from each other are vertical. So these two angles are congruent to each other and these two angles are congruent to each other. So if I look at the algebra, I could say that 8x plus 30 equals 7y minus 38. Unfortunately, I'd be mixing x's and y's together, and I don't necessarily want to do that. So instead, I'm going to look at the two angles that involve x. The two angles that involve x are these two angles. And these two angles are adjacent, and they're supplementary, and they form a linear pair. So the formula that I can write is 8x plus 30 plus 9x minus 3 equals 180 degrees. These two angles are supplementary, so when I add, I get 180 degrees. Now I just need to solve for x. Combine my like terms and undo what's happening to x. So I've solved for x. Now I need to solve for y. The two angles that involve y are these two angles, and these two angles form a linear pair, so they are supplementary. So that's my other equation. 5y minus 22 plus 7y minus 38 is going to equal 180 degrees. Combine my like terms. Solve for x, and then, solve for y. So I've solved for x and y. Now I need to find the measure of each angle in the diagram. Well, this angle is 8x's plus another 30. So if I have 8x's, I have 8 9's plus another 30. And this angle is going to be 9x's minus 3. So I'm going to have 9 9's minus 3. And this angle is 7y's minus 38, so I'm going to have 7 20's minus 38. And this angle is 5y's minus 22, so I'm going to have 5 20's minus 22. Now if I look, my vertical angles are congruent, and my adjacent angles are supplementary. 102 plus 78 is 180 degrees. Let's look at problem number 2. Again, I have vertical angles, and I have linear pairs. My adjacent angles in this diagram form linear pairs, and my opposite angles are vertical. So if I look at the angles that involve x, those two angles are vertical of each other. So I don't want to add them together and set them equal to 180. These two angles are going to be congruent. So the equation that I want to set up is 4x equals 6x minus 26. At this point, I want to solve for x. I end up with 26 equals 2x divided by 2. X is going to be 13. And if I look at the angles that have y, those two angles are vertical. And by the vertical angles theorem, those two angles will be congruent, which means that their measures are equal. So the equation is set them equal to each other and then solve. So I've solved for x and y. Let's plug those numbers back in to find the measures of each angle. So this angle is 4 x's. So I have 4 13s. And this angle is 7 y's minus 12. So I have 7 20s minus 12. And this angle is 6 x's minus 26, so I have 6 13s minus 26. And this last angle is 6 y's plus 8. And if I look, my picture makes sense. My vertical angles are congruent, and my adjacent angles will be supplementary. They form a linear pair. So in order to do problem 1 and problem 2, I first need to identify what kind of angles I have. If my angles form a linear pair, I add them together and set them equal to 180. If the angles that I'm working with are vertical, I set them equal to each other and solve for x. So first identify what kind of angles you have, then set up the equation, then solve for x.